So just like we spoke about on the video, it's giving us ordered pairs, it's giving us an x, it's giving us a linear equation, and basically the idea is you're plugging in for x and you're solving for y. You're plugging in an input, you're getting an output. Here, -3, I believe, -2 minus 1, yeah. And then we continue with other inputs, -1. Y is equal to 4 minus 1, 3. Y is equal to 5 minus 1, 4. There's less of a pattern here. And where we went over our lesson examples, there was more of a pattern, probably because the change in x was more the same. If you see, this goes up 2, 4, and 1. So if the change in x varies, then your pattern here will also vary. But basically, you're just looking at a coordinate here in x and y, -2 and -3. You're looking at a 0, -1. You're looking at a 1, 2, 3, a 4, and a 3. So the idea is to find those perfect points here. So here I have a -2 and a -3. Here's a good point. Here I have a 0 and a -1. Here I have a 4 and a 3. Here I have a 5 and a 4. These have proper plots. Like, yes, this kind of fits here, but the points that we're plotting, the -2, -3 fits most here. This is best fit with plots. This would be our answer here. Now we took a look at this as far as, okay, I need to get a y equals mx plus b. You can see that here. You can see a slope and a y-intercept. First thing we're going to talk about is our coordinates here, x1, y1, x2, y2, in which we want to find slope, 9 minus 12, y2 minus y1, and 12 minus 8, x2 minus x1. 9 minus 12 is -3 over 4. I know my slope is going to be -3 over 4, so goodbye to b and a. We have to use our point slope, in which you're using one point and one slope. Y minus y1 is equal to m x minus x1. Y minus 8 is equal to -3 over 4. X minus, actually this should be our 12. This should be our 8. Let's draw that again. Y minus 2, y minus 12 is equal to -3/4 x minus 8. Now I have to multiply and distribute that -3 over 4 times the -8. Some of my fraction principles, okay, I could cross reduce -2 and 1 because 4 goes into -8 2 times and 4 goes into 4 once. So actually I end up with a -3 times -2. I end up with a +6 here. So when I multiply -3/4 times the -8, I end up with a +6. You could have also multiplied across and got 24 over 4, which also gives you 6. Or you could put this into your TI-83 as -3 over 4 times the -8. Make sure you use that negative button on the bottom of your calculator, and that would give you 6. So I have y plus 12 is equal to -3/4 x plus 6. I want to subtract the 12 from both sides, and I would end up with -3/4 x, but it has 18 here, so maybe we made a mistake at some point. Yeah, this is negative. That's positive. That's our +3 over 4. Is this somehow telling me that this should have been minus 8? Okay, yeah, it should be minus 12, so I'm actually, this was minus 12, so I'm actually adding 12 to both sides, which would have given me an 18. If you see I made a mistake here, I had the minus 12 here, but when I brought it over, I made it a y plus 12. So actually we're adding the 12 to both sides. And here would be our answer. See, if you see our slope is the same, so we have to find which of these are a proper y-intercept, the negative 18 or positive 18. It would have been answer choice D. A couple mistakes there by me. Here's a graphing in standard form. Your ax plus by equal to c. Now again, you're just plugging in zeros for an x and for a y, so I have 3 times 0 minus y equals 3. Understand when you have a negative variable equal to a number, you can't leave it as this way, so we're going to change signs here. And we're going to make this a positive and make this a negative. Y is equal to negative 3. And that's where I want to plot here. I have a negative 3 here. I have a negative 3. I can eliminate, already start to eliminate answer choices based on my value for y. 50-50 there. Then I want to plug in 0 for y. 3x minus 0 is equal to 3. 3x is equal to 3. Divide by 3. Divide by 3. X is equal to 1. I like this color. X equal to 1. We have here. Here is a negative 1, so that's not going to fit properly. So here our answer choice would be A. I like this question here because there's some level of testing out answer choices to see which fits our table. Yeah, you could plot. You could definitely go ahead and just plot these points to these graphs. You know, I could plot my negative 2 and 9. I could plot my 1 and negative 2 and try to find that. Or I could test maybe this point here and this point here and say, okay, if I did here negative 7 times negative 1, that's my x, okay, minus y equal to 5. So I just plugged in my negative 1 for my x value, and I want to see, will my y end up being a negative 2, because that's a good fit. Negative 7 minus y is equal to 5. Subtract the 7. Negative y is equal to negative 2. Y is equal to positive 2. That's not the result I have here. I want a negative 2, so that doesn't fit. Now I say to myself, okay, I had the 2, but I want it to be negative. So I'm going to look here. They gave me the negative for the y, so I could say, okay, they're giving me the positive for the y here, so that means I won't have to change the sign. Negative 7 times the negative 1 plus the y is equal to 5. 7 plus y is equal to 5. Subtract the 7. Subtract the 7. Y is equal to negative 2. That's a fit. Let me test the y-intercept. Negative 7 times 0. So I'm testing another point here. Plus y is equal to 5. Y is equal to 5. That's a good fit here too. So if you see here, I plugged in a negative 1 for my x, and I've got a negative 2, which is what I had here. I plugged in a 0. So, and you have to be careful, because if I plug in a 0 for this answer here, just the 0, if I say 7 times 0 plus y is equal to 5, I'll get y is equal to 5. That'll work here. But when I plug in the 7 times the negative 1 plus y is equal to 5, I end up with negative 7 plus y is equal to 5, add 7, y is equal to 12. That's not a fit. That doesn't fit here. So if you see in one case the y-intercept fits, but one of the x-coordinates does not. And you could also go ahead and plot these points on one of these graphs, like the 2 and 9, the negative 1 and 2, the 0 and the 5, the 1. I mean, we're going off to 12s here, so you might miss some of that here. But plugging in these values from the table is a great way to find which one of these equations and graphs works. We've done one of these. This is good. I like this one here, 64. just basically because they're not providing you with a table, but they're telling you to solve for 1, 2, 3, 4, and 5. I like this because the change in x remains the same. So, and it gives you this function we're plugging into here. Y is equal to 1 minus 2. Y is equal to 2 minus 2. Y is equal to 3 minus 2. Y is equal to 4 minus 2. And you're going to see a pattern right away, 5 minus 2, where it's going negative 1, 0, 1, 2. It's basically going up by 1. Right away I can identify that as a positive slope. So goodbye to A. Goodbye to D. The slope is basically 1 to 1 here. So I could go and say, okay, where is 1, negative 1? That's here. 0 for y and 2, so 2 and 0. And you could see this graph. You could see this graph is going up 1 over 1, which is that 1 to 1 change. So x is changing by plus 1 and y is changing by plus 1. So easy to find here. Now if I wanted my y-intercept, don't forget your original equation is y equals x minus 2. And don't forget about y equals mx plus b. And this tells me my y-intercept is negative 2. And there's only two answers there that have y-intercept as negative 2, so I could have eliminated both of these.